What about this? First thing, frames of reference. So frames of reference is just how you view the motion. So one thing that's a little bit different maybe this year than last is that we will change our frames of reference or coordinate system when we view different problems. So we haven't done anything along those lines really yet. Like I've changed positive y from like the normal Cartesian plane from up to down. So that's kind of changing your coordinate system or making west positive when east is usually positive. So when we're looking at our coordinate system, right, if you're at a higher level or just in today's class, you kind of have to define what your frame of reference is when you view a motion, because depending on what you're doing, you'd see the motion differently. Right? And if you think like abstractly, this makes sense to you, because if you were, right, if you move in a car or you're on a bus or walking down the sidewalk and you compare what you see looking out a window compared to somebody who's stationary, you see things moving in different ways, right? If you look outside your window in a very weird way, right, you're like in a car or a vehicle, if you look out the side, it looks like the world's going backwards out your window. Right? It's not like you're moving forwards. It's like the telephone poles move behind you, right? Which you know tells you you're moving forward, but it looks like to you it's moving backwards. You do this in sports all the time, frames of reference, because everybody views plays differently, and we have to use relative motion to make successful passes in sports when people are moving, right? Or to get to an object that's flying through the air, because you have to figure out, okay, well, if I'm running this way and the ball's going this way, I have to, hit it at this angle to get it into the net type thing. Which you don't do obviously with your protractors and calculators, but your intuition kind of helps you along the way. All right, so we'll worry about those examples later. Going back to this though, when we talk about frames of reference, you'll see in the questions it's always defined as who's stationary and who's moving. Right, so normally, if you remember back to last year, you probably did like canoes in water or airplanes in the air. Did you guys do that last year?
Yeah.
Right, so all of those things, I think last year were in straight lines too, right? Like you're moving one way and the wind was blowing you behind you to speed you up or slow you down, right? So obviously this year things are on angles, so it's not forwards and backwards. So there are two types of frames of reference. The first one is the inertial frame of reference. So this is how this class runs, is that we always look at things through an inertial frame of reference. So that just means that when we're taking measurements or the person in the question is doing their thing, that their frame of reference is either stationary or moving at a constant speed. Right, so that's important. If we're in the other frame of reference, which is just the non-inertial frame of reference, that means that your object is changing speed. So it's speeding up or slowing down. And then the laws of physics that you know about or your intuition doesn't really help out with what's going on. So the person on the platform there, right, in the picture on the left, the person on the platform, as they're moving from left to right, he's stationary with respect to the platform, so that's his inertial frame of reference. So in his point of view, even though the platform's moving, if he throws a ball up, as you can see straight up, it falls straight back down into his hand, even though he's moving sideways. But relative to his surroundings, he's stationary, right? So it'd be like if you're on the bus going home tonight and you threw a ball up into the air, and it should land back in your hand as long as the bus is going at a constant speed, right? If the bus changes speed while the ball's in the air, that's your non-inertial frame of reference, and that's when the ball won't land back in your hand because it's still leaving your hand with whatever it had when it left your hand, but now your body's changing speed, so it's not going to land back in your hand. And that's the next one. The girl on the outside there, who's person B, I guess, she is also in an inertial frame of reference, so but her point perspective is different, right? Because she's watching the cart go by, and she sees the ball travel in a parabola because she's stationary with the earth and not moving with the cart. So even though the person on the cart seen it go up and down, so he would describe what's happening differently than the girl is, right? So they have two different points of view of the same motion. And if you get, like, if you're asking them what was going on, they give you two different answers, and both are right because it's based on their point of view. Does that make sense? All right, so it's the point of view that's important. So when you read a question, you have to digest to figure out what is the point of view of the question. So this is kind of all the things I just said. So your non-inertial frame of reference is one that's moving, and then there's the textbook, and everywhere you read kind of use the word fictitious forces. I don't know if they do that for the alliteration where you have two F's in a row. But they're forces that people make up, or your mind makes up, to kind of explain what's happening even though they don't exist. So that's what fictitious means. So they're not there. We have names for them. So these made up forces, like they have names, but they're not real things. That you would never actually use the forces in if you were doing like Newton's laws of motion. Any idea what a made up force would be? So one is like the centrifugal force. I don't know if you heard of a centrifuge before, right? But if you are going in, I always go back to cars. So if you go back, if you're going in your car, when you turn a corner in your car, your body leans towards the outside of the turn, right?
Good morning, everybody. If I can have your attention, please.
Uh-oh. If you are in the car, you're moving towards the outside, that's called a centrifugal force. It's a force that people use to describe, like there's like a force pushing you towards the outside of the car, but that's not what's really happening from a physics point of view. From a physics point of view, your inertia is just trying to keep your body going straight. And we'll look at that when we get into the circular motion part with forces again. The elevator one's another example, right? Because if you're in the elevator, especially if it's a fast one, that speeds up, has a fast acceleration, right? When the elevator starts going, you feel a little bit heavier there for that moment it starts up. Or when it slows down, if it stops suddenly, you feel a little lighter than normal at the top, right? So students or people might explain that as there's a force acting on them, pushing them up or keeping them down, but it's really just the momentum keeping them moving, right? There's another one called the Coriolis effect. I don't know if you ever heard of that, or the Coriolis force, and it's the explanation for why when you flush your toilet or turn the tap on and the water drains out, it always goes in the same direction, which is the same as why hurricanes and tornadoes spin in the same direction in any weather system. And it deals with how the Earth moves or rotates, right? Because the Earth's rotation is a non-inertial frame of reference, and it causes everything to spin in the same direction in the northern hemisphere. And it also falls under this fictitious force scenario. So there you go. Non-inertial frames of reference. And you know what? That sounds like a great place to stop before we get into math. Tomorrow, just so you know, we'll finish this off with relative motion, and we'll do the math examples, but again, it's just components with speeds. That'll be the first half of class tomorrow. Second half will be our quiz.